Hello my dear friends, this is in front of you 𝗧𝗏 𝗧𝗦𝗔𝗏 from TTWREIS Girls Indraveli Institution of Adilabad region. Before going to the class, let's have a beautiful thought for you that will boost you to listen the class carefully. See, here is the thought. Life has no remote control. Get up and change it by yourself. So, his life has any remote control? Obviously no, life don't have any remote control. So, sometimes life gives us kick and we'll go somewhere to somewhere and we cannot stop that. But there is a solution that is one and one only, that is education. By that we can hold our today and tomorrow in our hand by education. Okay, so let's move to the class. Let me drink a little bit of this. Yeah, this day is too hot and it's very difficult to speak. So, see, now I have drink this juice. It means here we see two types of substance. Those are, one is mango and another one is water. And what happens? We mix those compounds together and what will happen? Which type of solution it became? It became a colloidal solution. So, in this class, we are going to learn about colloidal solutions. So, before going to that, let's know about what is meant by solution, colloids and suspension. So, solution is a homogeneous mixture and colloid is a heterogeneous mixture. And when coming back to the suspension, it is heterogeneous mixture. And when coming back to their particle size, so in solutions the particle size is 0.012 1 nanometers, and when coming back to colloids, its particle size is 1 to 100 nanometers. And when coming back to suspension, the particle size is greater than the 100 nanometers. So, in solutions, particles do not be separated on standing and the particles are very small and we cannot separate them. In the colloids, particles do not be separating on standing, both are same, but in suspension it is opposite to them. In suspension, particles separated on standing. And when coming back to its another point, it has the particles do not scatter light, and in colloids particles can scatter a light, and in suspension particles do not scatter light. Is it clear? Okay. So, let me show you example. So, it is a water. I am mixing sugar here. What will happen? It will become a solution. Already we have seen that firstly it is a mango solution. It means mango juice, and it is a sugar solution. It will completely dissolve in it and we cannot observe the sugar particles after little bit of time. And that example for a suspension. See, it is a sand and it is water. I am mixing sand in a water. Let's see what will happen. See, here we can, at bottom we can see little particles. After a while we can observe all the particles get settled down at the bottom, and we can clearly observe the particles as well as those whatever are the compounds present in this solution. But here we cannot, and here also we cannot see the particles. So, this is a solution, colloid and suspension. Is it clear? Okay. So, let's move to our topic. Colloidal solution. Colloidal solution. So, discuss, before going to purification of colloidal solution, discuss about colloidal solution. particles suspended uniformly in a solution. It look like an homogeneous, but it is actually heterogeneous mixture. When coming back to its size particle, as we have discussed it just now, so its size particles is from 1 to 100 nanometer. It has a scattered beam of light, and particles cannot be separated through a colloidal solution. And we can see a number of examples for this colloidal solution, as we can see milk, butter, blood, ink, jelly, number of examples we find for this. So why we should take a milk only as a colloidal solution? Let's see. Milk is a colloidal solution. In milk we find many more substances like fats, calcium, protein, and some other also substance we can find here. So in a milk, all the protein part is up and all the fat and other enzyme is down. It will happen here? No, it will not happen here. Here particles are arranged equally in a solution. So how much particles are up, that much particles are down. So it is about a colloidal solution. So now let's discuss about purification of colloidal solution. So purification of colloidal solution, it is a heterogeneous mixture of two or more than two substances. What is mean by heterogeneous means? Heterogeneous means a solution containing more than two components is called as heterogeneous mixture. So this process consists of three steps or methods. They are dialysis, electrodialysis, ultrafiltration. So before, let's go through the dialysis. See, during preparation of colloidal solution, excess electrolytes and some other impurities remain within the colloidal solution. So these impurities can be removed by diffusion. Diffusion, we all know what is meant by diffusion. The movement of molecules or gases from high concentrated place to the low concentrated place. So by using a suitable membrane. A membrane containing a continuously flow of fresh water and a membrane containing a colloidal solution is suspended in the vessel. That membrane containing small pores, from these small pores excess electrolytes and some other impurities get diffused from solution to water, and then we remain with pure colloidal solution. So up to here it was about dialysis, and the next step, that is electrodialysis. We know here electro means electricity, and you may think that we are going to use electricity in this method, then absolutely you are right. So guys, electrodialysis. Dialysis is a slow process. To make this process faster, electric field is applied. This method is used when electrolytes are impurities. So when we can see electrolytes are positively or negatively charged. When electric field is applied, they get attracted by the opposite electrodes. So by this method we can make dialysis process as a faster process. So this is called as a electrodialysis. And the next one is ultrafiltration. Here special filter papers are used to get pure colloidal solution. As I will show you in the PPT also you can see that filter papers. See, these papers, it means special papers, are used to get a pure colloidal solution. Size of the pores are reduced here to avoid the diffusion of colloidal particles due to the small size of the pores. So, and this process take more and more time, as nowadays how the signal is passing in a speed way and how the generation is passing, moving on, it's also moving in a speed way. But here this ultrafiltration process is na, what it think? It think, let them go to hell, I'll do my work at my place. It means it do not it do not compare with any self, and it will do its process slowly. Okay, are you all interested to do the experiment? Are you all excited? Yes, me too, I am also excited. Then see, we'll do here experiment, and that is to prepare a follicle, to prepare a 𝗬𝗏 solution of egg albumin, means it is one type of a colloidal solution. See, this what are the apparatus we needed? First, this flask, stand, beaker, and sodium chloride, egg, it's a chemical, and NaCl2 sodium chloride, it's also a chemical, and spatula, and this needle. So let's start the experiment. Let's start the experiment here. What should we do? So let's take this empty beaker, and now break this is egg, and break its outer layer. As we are breaking its outer layer, and it's now this slowly we'll remove this outer layer of the egg, and remember that very well, we have to collect only the white liquid. It means it containing the protein part in the liquid. Remember guys, we should take only and only the white one, not the yellow yolk. So see, this was going the thick part, which is upper layer, and now this all we can see here. This is a light thick. As we are collecting it, yes, enough. So this is an white liquid of egg. Let's take 100 ml of water. This is 100 ml of water, and what should we have to do next? Then you can see, I have already prepared a NaCl sodium chloride solution, and in 100 ml of water we have to add it. So we are going to add it. Enough. Let's stir it for some time. Now slowly we add this solution, egg albumin, in this water. Okay, completely we have added it, and stir it for some time. See friends, it takes more time to get dissolved. For that, already I have prepared another solution, same like this also, like this. See, it is also smell same, but I have prepared it before, because it will take more time. because it will take more time to get dissolved. Now what should we do? Now we should take a filter paper. It is a filter paper. Let's fold it like this. Once, this is twice, and let's do this like this. Let's fix it in a flask. And now we should pour this colloidal solution in it. See, ultrafiltration processes begin. The water droplets are coming. How amazing it! See, you people get doubt, why don't we use ordinary paper? Why should we use these papers only? Then see that ordinary papers are they are not capable of this. They don't have capacity to hold this, as they get spoiled, tattered or dissolved with water. But these special filter papers are made specially. So these papers are having capacity to filter any type of solutions. See, the processes begin. The pure colloidal solution is coming in the beaker. Okay, is it clear? Are you all got my points? So next, if I ask you, how many of you are going to theater to watch a movie, then you will say I, and I. But have you noticed that how the light is coming from the projector and why the screen is looking big, and how we can see the rays of sun setting or sun rising, why we can see a beam of light in a room filled with a dust. And one more thing, if we go top of our house or of the terrace, then we'll on the torch, what will happen? See, the torch light is coming from a small hole, but after coming into the atmosphere, it's occupying more space. What is the reason behind it? Is it due to reflection of light, refraction of light, or dispersion of light? The answer is none of this. It is due to completely a different phenomena known as scattering of light. Okay, and a beam of light can be passed through a colloidal. What is the phenomena known as? Absolutely, you are right. It is known as Tyndall effect. So, Tyndall effect, firstly observed by the Faraday. He studied the effect and laterally he termed as a Tyndall effect, named as it Tyndall effect. So, what is mean by Tyndall effect? Tyndall effect, that we can see light from the projectors, from the torch light, from the atmosphere sun rises. So how is it? The Tyndall effect is due to the fact that colloidal particles are scattering the light in all the directions. See, Tyndall effect is observed during the projection of cinema hall. And how is it observed? In that hall, smoke, dust, particles are present. Those particles scatter the light, and through we can see the light or picture. So, is it clear? So, light can be scattered by dust particles, air molecules, water droplets, etc. So a beam of light can be seen through a colloidal, that is known as scattering of light, as we discussed. And when we can see this, we can see only when the two conditions are satisfied. Those conditions are: diameter of the dispersed particle is not much smaller than the wavelength of light. Okay, it means the dispersed particles do not have much smaller than wavelength of a light. The refractive index of a dispersed phase and dispersed medium greatly differ in magnitude. So hope let's recall our class once again, because if we recall any classes, then we can remember it a long time and we cannot forget it. So in most of time, what they do, they just study it one times and they let it be it and close it. It is not good. So we have to recall what we have studied, what we have learnt, so that our memory will store all these points in our mind. Okay, so let's go back and discuss. As in a solution, we have discussed about 3 types of solution. What are the solution? Colloidal solution, suspension. It's homogeneous, heterogeneous. Particle size 0.01 to 1 nanometers. Particle size 1 to 100 nanometers. Particle size is greater than 100 nanometers. Particles do not separate on standing. Particles do not separate on standing. Particles separate on standing. Particles do not scatter light and particles scatter light. So we have prepared here what we have made here: solution of egg albumin. See here how it was coming in the experiment. How much I poured? Maximum 95% all that collected in this beaker. This type the filtration process became in the dialysis process. What we have done, it was slow and we have made it fast by connecting electricity. After that we done filtration. By that we can see here, and later that we will know about the Tyndall effect, how the light is passing. So it's all we have learned in this class today. So I really feel very thankful to our secretary sir, my dear principal madam, my subject teacher and my dear friends who those are supported me, and a lot of thanks to TSAT channel to give me this golden opportunity. Thank you, and let's meet in next class with this spirit. Okay, bye.